Good evening, everyone. This is Binu Mishra and this is Mr. Kaushik and my friend, and we are the students of Mechanical Engineering in Dr. K. Modi Foundation. And today we'll show you our workshop and our autonomous bot, which we have worked upon.
Various kinds of bot that we have made till now. And you can see this is my room, Kaushik, and this is Binu Mishra, my good friend, and also my teammate. And this is my room, and actually you can.
This is our small little workshop.
Yeah. You can see everything is just out of order, and I have no books, nothing, only the machines and all that are visible. So the first robot that I started with was this one. This one was my life's first robot, which I made in class 7.
Actually, this he made for his child, which he decided that he'll give to his child when he gets birth. But now it doesn't work, so it
doesn't work.
We'll make a new one for
but
you.
it has good memories.
Sweet memory.
Sweet memories. It was nothing, just a manual motor operated from 1,000 switches and all that.
We will discuss that afterwards. Now we'll show you our bot, manual bot, which we took to IT Kanpur.
Yeah.
This is quite out of order, but this bot got us AIR 7.
Integrity 2012.
Yeah, and the event was Isle of Tortuga. Yeah, and let me show you.
Introduce the arm. This one is the arm that my life's first robotic arm that we made together. It had 3 degrees of freedom, as you can see here. I can't show it.
And let me tell Kaushik that 3 degrees of freedom is not easy to make. It is quite difficult.
And quite a tough task to make. You can see as the motor, the first degree of freedom motor is not hinged properly now, but it works right there very smartly. It works.
Yeah, that is why we got AI 7, man.
This is the first degree of freedom. This is the second one for holding things.
And it goes clockwise and anti-clockwise 180 degrees.
Clockwise and through this motor. This is the third degree of freedom. Yeah, this one.
So you got it?
So you got it.
Now we'll show you our new mod.
Let me keep back the arm and so we'll show you the drive mechanism. But he used in the drive because the arena was quite tough to make.
It had a number of obstacles which
obstacles and a 17-degree elevation.
More than 70. Around 25 degrees.
Yeah, around 25 degrees. So what I thought that why shouldn't we apply belt on our wheels?
Yeah.
So what we did that we had wheels, we made a cut on it, made a single slot, slit, and we placed these belts over it. These belts have some elevation or this kind of something. This one, which fits compact into this slit and doesn't allow wheels to
slip away.
So it was our mechanism and it worked very, very efficiently.
And the best part was that these wheels helped us to pass a depression of width around 8 centimeters.
8 centimeters, yeah.
And very easily we got to that.
We very easily got through every obstacle that was in the arena.
The only thing that mattered was the arm, and in the finale it got busted.
Yeah. And let me introduce you the batteries which
we had used.
And these are 3 batteries in series each. This is 4-volt battery, and together we added it to
make a 12 volt, around 12.35 volts. And these are lithium-ion batteries.
And what I can say, I cannot define our luck or what you think about that.
Just leave it now.
We'll not explain about our failure. The only thing that we'll explain is about our achievement and everything. As you can see here is our workshop, a little kind of workshop. We have every kind of boat. We have worked on manual autonomous boat. This is our.
A self-made robot APM kit, which works on programming basis. That is known to everybody. This is the microcontroller.
My first ever development board that I ever used the programming. This is the Mega 8 board.
Yeah, at Mega 8.
At Mega 8 board, this is a chip. This is the motor driver.
And the motors are 100 RPM, yeah.
And these are the infrared sensors. We can make a number of robots through this. Obstacle avoider, line follower,
satellite control,
mobile controls.
Yeah.
On basis of that, C has programming.
Yeah.
On the basis of that.
Without extending this, let's introduce a new bot, the autonomous one.
Yeah.
Now,
And one thing more is we have to tell
Mr.
that.
Kaushik will continue with his achievement.
One thing, what I had pre-decided to put these belts over that rubber one. These belts had a problem that the belt sometimes on the arena we had faced the problem that it got displaced from the wheels.
Yeah.
You know,
Yeah.
the belt got displaced just like this from the wheels. So what I made a system to sort out this problem. I made these kind of belts. You can see here. These kind of belts.
Explain the mechanism.
Yeah, it is simple wood, and I have hinged it on the bike chain. It is the chain which is inside the engine of the bike, and just drill the
Rotate
wood
the wheel.
and the wheel have to be placed inside. So there is no probability of slipping over the belt. No, you can see here, no, nothing.
That was only one fault which we made.
Then that was only one fault which we made. The belt was quite heavy, but it was good. We didn't use it. So
And now moving on.
introduce you to our next bot that we are currently working on. This is our line follower robot.
Now, see, I'll tell you, as we shown you the chip, it is the same microprocessor with the same sensors at 8 MHz, and the motors are different. They are around
The
60,
motors are different. They are of 60 RPM.
60 RPM.
And there is another different thing here. Caster wheel used, Omni wheel, which provides direction to this. And the battery used here is also of high voltage.
Yeah.
1500 milliampere and 12 volts. Although we are using just 8 volts from this 12 volt.
But just to check out
and how it
efficiency.
works and how we have did the programming, we have did all things, and just we have checked. We're gonna check.
Now this bot will follow a black line. It is a line follower bot which is going to follow a black line.
Black line on light surface.
On light
You
surface.
can see
Yeah.
there is a color difference between this path and this surface.
path.
So what it does is that it differentiates between the colors, and it senses where to go by sending signal to the motor by this microcontroller. I'll show you the way.
Yeah, I'll definitely do that. Just see, it will follow the same path as directed, and see, as you can see, the path is quite complicated at different angles, but still the bot is going on. So you can see the efficiency of the bot.
The path
Yes,
is
sir.
quite difficult, I suppose.
Yeah, because of the turns and the angles which we have taken. Okay.
So it has made one complete rotation.
Still going on.
Still going on. It can practice for hours. Doesn't matter to it, huh?
It is not a manual bot. Neither it is a human being. It's a bot. It will go on.
A perfect something you can say. Perfect kind of thing.
Just focus on the angles which are given.
Just focus on the angles, how it follows it. And underneath the board, you can see it looks like neon lights glowing on, huh? There is some kind of obstacle over there, so we have to push it manually.
बंद कर दो.
So, made two rotations. Yeah, this is we are working on this robot we have made for the Cognizant.
Cognizant.
At IIT Roorkee.
The tech test,
Tech test at
India's second biggest tech test,
At IIT Roorkee.
and
we have
hopefully
prepared.
will qualify.
But the problem is that we have to make two robots simultaneously and operate both of these.
Yeah. But this has to work on its own, so
This has to work on
the
its
main
own,
problem is
and
the manual robot.
we have to control all we have to control is a manual boat. And as you can see, this is our workshop.
Kaushik, let's make it, let's finish it. The workshop we have shown. So this is up for now. Next time we'll see you again with our manual bot. Thank you very much.